Now, I say 5 types because that's what I've done in the past. One of those, the last one we're going to talk about combustion, we may just kind of introduce here, and then when we do our organic unit, we'll talk more about combustion. So it's really kind of the big 4 that we will talk about. Synthesis is the first one. You will want to jot down and memorize the generic formulas, and this is what you should put on flashcards. So again, I'm encouraging you guys, nothing beats the old school methods of making flashcards and looking at them every single day. That's how you're going to remember it. When you get into your test next Wednesday, now if we have a snow day, if we were to have a snow day tomorrow or something like that, which we'll look at your app maybe at the end of class.
56.6%.
Tomorrow?
99 to 26. It's going to go from like 56 to -12.
To -12? That's not possible. But anyway, if we had a snow day, guys, we probably would end up pushing that test back to Thursday of next week, which I know is right before break. It's not what I want to do, but if I want to give you guys enough time to prepare you. So we'll talk more about that if that even happens. Let's hope. All right, but what you will want to do is of the 4 types of reactions, I highly encourage you guys to write down these generic formulas because they're showing you what's going on. Okay, so synthesis is when you have 2 or more substances combined to form one new substance. So if on a flashcard, on one side I would put synthesis, on the other side I would write this general formula, and the other thing I would add to it is you have one product. Okay, synthesis forms one product every time. What does synthesis mean? When you hear that term synthesis, yeah, you're combining, you're making something new. All right, so some examples that you could see. We're going to do this reaction in just a second. So we're going to list 3 or 4 examples of different types of reactions with actual elements so you guys can kind of see what's going on. So the first one is we're going to have magnesium solid plus oxygen gas. All right, and it's going to yield MgO. Remember, this is the one I said, oxygen and magnesium got together and everyone was all like this. Yeah. But obviously that's an incorrect way because which has to come first? The cation has to come first all the time. And that would be a solid as well. Now this reaction requires a little bit of heat. So remember, your symbols this Friday, you've got vocab, which is due tomorrow. So be prepared.
I already did that.
All right.
I did
That's what you did do last night? Okay. Even though you had 2 days for that and the other homework was due the next day. But hey, at least that's done. All right. But vocab, guys, is due tomorrow. You've got a vocab quiz, diatomics, and symbols quiz on Friday of this week. All right, so this is what we call the formation of a binary compound. Okay, formation of a binary compound. That's what type this is. When we take a look at this reaction, it's a single element plus a single element. Why is this a single element, guys? There's 2 of them, though. How can that be? It's not a single. Is it a single element?
It's a diatomic.
It's a diatomic, right? Those 7, Brinkelhoff. Remember, that's what you should write down at the top of a page or on your quiz or on your test. Brinkelhoff. Anytime you see these 7 by themselves, they exist in a diatomic state. They're bonded to another atom of the same element. All right, it's still considered to be a single element, though. All right, the next type we have, an example could be calcium oxide plus water, and that's going to create calcium hydroxide. This is what we call a metal oxide plus water. It's going to make a base. All right? Which one? Metal oxide. Because it's a metal with oxygen, so it's a metal oxide. So notice, now we've got 2 different compounds combining together, but it still forms one product. That's the key, guys. It doesn't have to just be binary, so it's 2 elements forming a compound. It could also be 2 compounds forming a new compound. But the key here to help recognize synthesis is that it's got one product. That's the key. That's what you should put on your flashcard, is that synthesis always have one product. Okay, one product. And the last example we're going to do is going to be similar to letter B, but it's going to be sort of the opposite. Instead of a base forming, it's going to be a non-metal oxide. Now, plus water. And that's going to make an acid. So a metal oxide produces a base. Non-metal oxides plus water produce an acid. Decomposition, guys, is the opposite of synthesis. Decomposition, what do you think of when you hear that term decomposition? Breaking down, right? Decomposing. So when you're driving down the road and you see like Bambi or Thumper on the side of the road, they're decomposing, right? I know it's kind of graphic there, but you get the idea. They're breaking down. You can't get them back to where they were. So here's the idea. Single substance, it's going to produce two or more simpler substances. Okay? So it's kind of flipped. It's the reverse of synthesis. So on your flashcard, how do you know decomposition? One reactant. Okay? One reactant and one reactant only. Synthesis has one product. Decomposition has one reactant. So those two are kind of, to be honest, in my opinion, decomposition is the easiest one to identify. It's only got one reactant. You know right away it's got to be decomposition. So we got a few different examples here. I'm not going to write all of these down. So we're going to keep things simple. This is the one that we're going to do here in just a second. So we're going to take hydrogen peroxide. We're going to break it down into water and oxygen gas. So this is where we have a binary compound breaking into elements. Is that equation balanced? No, balance it. Calcium carbonate breaking down into calcium oxide plus carbon dioxide. This is a metallic carbonate breaking down into a metal oxide. Okay. Plus water. So electrolysis, like here at the bottom, the classic example is the electrolysis of water, where you can take water and you break it down into hydrogen gas and oxygen gas. And if I, at some point this year, find the apparatus, I know where it is in the back, but if I can figure out how to get it working, we would actually do this and I would show you. You can actually see that there's twice as much hydrogen being produced as oxygen. So it's a really cool way to show that. Will we do it? I don't know. I can't promise it. But the difference with electrolysis is that it's a specific type of catalyst where electricity or charge is applied that allows it to start to break up. Okay? The example that we wrote down here with magnesium and oxygen, where it needed the heat. Magnesium, if you just leave magnesium out in the air, it'll start to oxidize and react with oxygen. But that takes a long time. All right? If we add some heat to it, it can go quicker. And that's what we're going to do here right now. We're going to go finish up the lab from yesterday.